In this video, we will learn the statement and proof of the quotient rule for derivative. We will learn both the statement and its proof. Now, the statement of quotient rule is, suppose f and g are defined on the interval ab. So, the function f and g are defined on the interval ab and are differentiable at a point x which is in AB. Then the conclusion is, then f over g is differentiable at x, and the formula for quotient rule is, and f over g prime of x equals to g of x whole square and g of x times f prime of x minus g prime of x times f of x. So, this is the formula for the quotient rule. Now, we will prove it using the definition of derivative. So, to prove that, what we will do, let h equals to f over g, then for any x in AB, we have from the definition of derivative h prime of x equals to limit of t approaches x h of t minus h of x over t minus x, where this t is in the interval AB and t is same as x. Okay, this is the definition from the derivative. Now, what is h? H is f over g. So, plug that. So, limit of t approaches x, f over g of t minus f over g of t over t minus x, and this can be rewritten as limit of t approaches x, f of t over g of t minus f of x over g of x over t minus x. Okay, we can rewrite that way. Now, limit of t approaches x, if we factor, now the common denominator for this part is g of t, g of x. The common denominator for this part is g of t, g of x. So, if we write this way, g of t, g of x, then in numerator it would be f of t, g of x, f of t times g of x minus g of t times f of x, g of t times f of x, and we also have t minus x. So what I did here, the common denominator for this part and that one is g of t g of x. So I write it here, and if you multiply f of t g of x minus g of t f of x. Now limit of t approaches x 1 over g of t g of x. Now f of t g of x minus, we will subtract first f of x g of x, f of x g of x, then we will add f of x g of x. So nothing changed, those will cancel and we can go back to the previous step. Minus g of t f of x over t minus x. So I rewrite this way. Now limit of t approaches x 1 over g of t g of x. Now here what we can do, from this part we can factor out g of x. From this part we can factor out g of x. So g of x, and then we have f of t minus f of x over t minus x. Similarly, from this part, from that part we can factor out which one? F of x. So if we factor out f of x, then we have g of x minus g of t over t minus x. Now if we use the properties of limit, then when t approaches x, this one remains same, but it becomes g of x. So g of x times g of x, it would be g of x whole square. So here we will have g of x whole square. Now when limit of t approaches x, this one becomes g of x, but this part becomes, by the definition of derivative, f prime of x, plus if limit of t approaches x, this one remains same, f of x, but when t approaches x, this would be t minus x. So, but in numerator we have g of x minus g of t. So if we write g of t minus g of x, then there will be negative sign here. So there is negative sign here, and it can be written as g of t minus g of x, g of t minus g of x. Now we can use the definition of the derivative, and if we use the definition of derivative, then this part becomes g prime of x, g prime of x. So this is the product rule. This is what we need: g of x f prime of x minus g prime of x f of x over g of x whole square. Thanks for watching.